This is weird. Like, really weird. A conference for Node? Man. So I actually have nothing interesting to say. I don't do anything interesting these days. I just fix bugs and try to progress Node. You know, there's a lot of work to do. And so I'm just going to talk about what is happening in the next version. Is that okay with you? Okay. It's going to be extremely boring. You can like go get coffee if you want. I will not be offended. I wanted to do a more interesting talk, but yeah. All right. So first of all, well, I just put this slide in here because it's somewhat amazing. Like Node seems to be attracting a lot of people to it. There are 4,000 people on the mailing list, and if you go on the IRC at noon on Pacific Standard Time, you'll see 600 people idling there. It is kind of a lot of people. There's books and several books coming out. I guess the Japanese book is going to be the first one. It's 500 pages and will probably be done, I don't know. When is it going to be done, guys? Like a month? End of June. Okay. Of course, most of us can't read it, but we can look at it, and it'll be pretty. Tom is working on a book. I think there's some others in the works. There's translations into various languages, and we are spamming Hacker News all the time. Because, I don't know, we like to click the up button. Okay, so May 2009, initial release. Then we did the first stable release, which was 0.2 in late 2010. And we just came out with 0.4, which kind of had a bumpy first few versions and is still a bit bumpy with SSL and stuff. But it's getting better. Starting to feel kind of good about the new stuff that went into 0.4. So 0.4 was all about fixing SSL. And doing HTTPS and oh. Thank you. Hello? Did anybody hear what I just said? No. Okay. So 0.4, I mean, the main focus was fixing the HTTP client interface and fixing the and doing SSL properly. With much thanks to Paul Querna and a lot of other people who worked on this. So 0.5 is our next unstable release, which we're already working on. And the stable release will be 0.6, and that will be in about 2 to 3 months, hopefully. So the goal of this basically is Windows compatibility. We are taking it very seriously. To which, you know, most of you people with all your glowing icons out there on your laptops, I see, probably don't care so much because the typical response from web programmers is like, what, Windows? I mean, who uses that? But actually, believe it or not, I'm sure some of you believe it, that Windows does account for a large number of the computers in the world. In particular, servers. There are a lot of, what's that exchange thing? Yeah, mail thing that Windows people use. 33% of servers, according to Wikipedia. We want that market. Like, for Node to really be gain its total world domination, we have to target that audience. It's not acceptable to just ignore that and continue onwards. So we do have a Windows port currently, but it's Cygwin, and nobody likes Cygwin. Everybody hates it. It's just kind of something that you do to get by, and it's buggy and it's slow, and you wouldn't really run a server off of Cygwin, but you know, it's a nice stopgap to help Windows people get going. But from what I hear, it's much better to just spin up a VMware instance of Linux and run Node there rather than in Cygwin. That's not a real Windows port. So question, I guess a reasonable question is it even possible to do decent servers in Windows? Like, obviously, like the rest of the OS is so awful, like it would not be surprising that, you know, it is just simply impossible to write a decent server. And by decent, you know, I mean, could handle 10,000 idle connections and not, you know, just churn and spin to death, right? So it is possible, actually. Microsoft does have smart people, and they do have, you know, fairly advanced techniques in the APIs, but it's not the same as UNIX. And I think that's why a lot of software doesn't actually make the jump from Unix to Windows. We are going to make the jump. So in Unix, a good server software would mean that you do non-blocking sockets and that you use a constant time I/O multiplexer like KQ or ePOL. Like, this is the definition of, this is what you must do on Unix systems to create a reasonable server. Windows has the Unixy select, but it's not constant time. And that means, like, when you load it up with say, more than 100 file descriptors, it becomes slow. It doesn't scale with the number of sockets that you want to load on this, right? You're polling for file system state, for file descriptor state changes, and it can't do that in a reasonable amount of time. It has to scan over all these sockets all the time. So they also have this thing called WSA event select, which is better in that it doesn't have the same properties of having to scan all the file descriptors every time. But the polling mechanism, which is WSA wait for multiple events, these people and their names, and is actually limited to 64 file descriptors per thread. They're actually not file descriptors, they're handles. 64 sockets per thread. Great, yeah, good choice. Like, what, why? 64 sockets per thread? Like, no, we want 20,000. Like, this is ridiculous. So that's awesome, right? So at which point you learn these things and you're just like, well, I guess our server is going to suck on Windows, you know? But we are nerds, and so we get into reading documentation for long periods of time. And you find out that it is actually possible to write really good servers on Windows with something called I/O completion ports. It's just that I/O completion ports don't act the same way. It's not the same concept as what you have in Unix. In Unix, you are, as I said, you're waiting for file descriptor state changes. So you're waiting for, you know, that socket to become readable so that you can read from it, doing a non-blocking read. Or you're waiting for that socket to become writable because you've got a big buffer of stuff to dump to it. In Windows, in I/O completion ports, it's rather that you write to the socket and you get told when it's done. So the kernel manages the send buffer for you. And when you want to read from the socket, you just read, you give it a buffer, you read from it, and then you go away and it calls you back in the future. So somehow it's a higher level interface. IOCP also supports pipes, which is cool, but whatever. But regular files is really interesting. So you can actually have real asynchronous file I/O in the kernel on Windows and not have to do these tricks. So if you're familiar with how we do this in Node, we also do asynchronous file I/O, but we have to hack it. So we have user space threads that we execute system calls in, which is, I mean, totally stupid, but there's no way to get around that in Unix. One point for Windows, right? The good thing is that Node's API, as we present it to users, is already IOCP basic, or whatever, is already IOCP-ish. So you do write to a socket and you get a callback when it's done. You just receive data from sockets. So you don't have this kind of interface where you're polling for file system for file descriptor state changes. What does that mean? It means that we can probably rework the plumbing without changing the user-facing API. So it's likely that 0.6 won't have any API changes, or if so, relatively minor ones that we just have to fix. But rather, the whole plumbing will be reworked to deal with this. There have been some other attempts to create a server library that works on both Unix and Windows. But somehow none of them are acceptable. Libby V, which we use in Node currently, is very Unixy. It's a perfect abstraction over Unix I/O multiplexers. On Windows, however, it just doesn't have, Libby V is all about file descriptors and if they're readable or writable. It doesn't port onto IOCP. You can run Libby V on select on Windows, but as we said before, that's somewhat unacceptable. There's libevent. So libevent 2 did some plumbing of their own and now runs on IOCP on Windows. But at least one person pointed out in a mailing list post that it's really bad. Like, I don't know, you can push like between two sockets, you can push like 100 megabits or something, like through the loopback. Like, it doesn't seem like they've done a very good job of doing that. Like they did a lot of work to sit on top of IOCP, but somehow they didn't achieve actual speed. So fail. It also libevent doesn't deal with, it's only dealing with sockets, right? And then there's boost ASIO, which is this C++ monstrosity. You have to download it. It's about 60 megabytes of source code, and like it's just so many files and so much API. Apparently, it does work though. They do actually give you ePOL on Linux and IOCP on Windows. But it's just so massive, and it's just like, seriously, is this such a hard problem? Like, all I want to do is like write to a socket. Like, this is not such a difficult problem that we really require 300 files and 12,000 semicolons is what I WC-L'd. So it also doesn't support regular files. This is all crap. Like it's not all crap, but it's just not acceptable for what we want to do. And I just think the problem is not that hard, especially now that we have Libby V on Unix, which is a very sort of thin layer. We can use Libby V on Unix to prop up this system, and it's done most of the work for us for most of the operating systems. And then on Windows, we have IOCP, and so we just need to make like a little layer over that. So that's this thing. It's called liboio. It was called libol, and I think we'll change the name again just to confuse everybody, because nobody will actually use it. So currently, this is being done in a separate repository than Node. But that's just to kind of maintain purity. We want all of our tests to be in C, and we want to make sure that we're not tempted to jump into some WAF loveliness and use Node to do the testing and stuff. We want all this to be very pure and just dealing with the C system. So it's actually working. The TCP socket and server stuff basically is more or less working. There's probably some bugs still. So we're writing a lot of tests, and actually I would like to ask if you are interested in system programming, or you're somehow interested in this problem. A great way to get involved with liboio is to go in there and write a test. I mean, the tests are huge because they're C, and you have to set up servers and stuff, and it's not incredibly fun, but we do need some. The main point of this is that we have two different implementations, and so testing is everything in this system. So since we have the socket stuff, the TCP socket stuff worked out more or less, we're probably going to be dropping this into Node Master very soon now, like next week, which will just destroy everything, but that's okay. Bert Belder of CloudKick is doing the Windows side, and I'm doing the Unix side. So here's the nice architectural diagram. It's actually not that nice, but it should be in two squares, right? Because one's representing Windows and one's representing Unix and whatever. But you get the point, is that IOCP is kind of a higher level interface than what Unix provides. It's somehow more abstract. And so we kind of are sitting on top of that. And on Unix, we have to kind of shim that up with some extra libraries, the Libby and liboio. So the goal of this is to avoid if-def hell. We don't want the entire source code of Node to just be littered with these preprocessor branches that have different implementations of every function. The goal is to push all the platform incompatibility into this liboio, well, as much as makes sense, obviously. Like, we don't want to get crazy about this, but let's get crazy a little bit. We'll push it all down, and then so we'll have all the platform stuff into this C library, and then the binding layer and the JavaScript stuff should, in the end, be completely cross-platform, ideally. That's not the case right now. So if you look at libnet.js, I told you guys this would be a very boring talk. I apologize. I'm sure there will be like very nice. I think Substack made a Markov generating wrap IRC log thing. This will be fun. Yes, so we will avoid if-def hell. Another component of Windows is that Windows users don't typically have compiler tool chains. So we want to distribute executables. And one thing that we've tried very hard in Node is not to dynamically link to everything in the entire system, although you give it to the Debian package maintainers and they're like, static linking, you guys are idiots, let's tear this apart. Debian, God. So I'm glad that's getting some applause. There's probably one guy that's like a Debian package maintainer. Yeah, right. Fucking Node. They call our executable Node.js instead of Node because there's some like ham radio Node executable? No, we will get Node, okay? The ham radio thing can change its name. Right, on Windows, have you ever downloaded Putty? It's like an exe file. So beautiful. Like, I love that. You just download it, you run it, it works. That is basically what we will be able to do on Windows, possibly, if we're careful. So I would like to get to the state where we literally distribute a .exe file, and people can download that, and now they have Node. Yes. It will be a nice user experience for the Windows people. NPM, the package manager, has a concept of building add-ons, right? If you download, I can't even think of a library now, something, there's all these add-ons, it will run through some GCC commands, right? Windows users don't like to do that. They want binary stuff. And actually, a lot of Unix users also want binary stuff. So Isaac's been working on augmenting the package repository to store binary compiled versions of the add-ons so that most people will be able to download and just get a pre-compiled DLL. And something that I really want is long stack traces, which I won't go into what that is. Basically, stack traces that span events when you hit an exception. This will, okay. Clearly, that's a point of contention. Yes. So the primary thing that's preventing us from doing that is that we need entry points from the event loop into JavaScript, and we need to know where all of those are, and we need to have a hook that is unified so that we can do stuff there. And currently, it's just spattered around the system. It's just very hard to organize it. We don't have kind of a single entry point where we can say, okay, now we are leaving Libby V and going into JavaScript land. So with this plumbing reworking in mind, we know that we want that, and so we will take special care to get these hooks in there. As I said, we don't want to go the Libby V libevent2 path. So if we can't get gigabit throughput over the loopback with a pair of TCP sockets and have like 10,000 idle connections on a server on every OS, then clearly we have failed. So hopefully that will not be the case. So we're trying to do benchmarking and testing early on in the development of this library, so that so we don't like wake up and like a year after our big refactor, somebody mails the mailing list and says, oh, I did this benchmark and it's terrible. No, so hopefully we will know what we're doing. That is the end of my talk. You can ask me questions. So the question is, are there any big things that that we have to give up in order to do Windows? No, actually not. What we have to do, the big thing that we have to do is we have to push some of this code that's written in JavaScript now, the lib.js, into C land. And it's unclear right now if jumping between the C++ boundary and JavaScript, which we will possibly be doing more of with this new binding, because whatever, that may affect performance, but we really won't know until we get there. But otherwise, the binding is very thin. We're not doing a bunch of magic stuff here. So we're just kind of massaging the APIs into place. So no, I'm confident that we're going to maintain our performance. So the question is, have I thought much about what comes after Windows compatibility? Yeah, there's some more stuff we need to do still. In particular, there's a lot of cleanup stuff that needs to happen. But we are quickly approaching a stable thing. So there's not a ton of reworking. I want to do this thing now because this is going to basically be rewriting Node. We have a lot of tests now, so we can kind of, with some confidence, say that we're going to actually make it. Yeah, we're quickly approaching a 1.0. Don't worry about it. One thing I've learned is that, like, if you're not, we will make every effort to make every piece of core API work on both systems in the most decent way. Oh, by the way, the question was, how can you prepare for Windows API, blah. Just hold off, right? We might just crash and burn here and the world might explode. So, don't worry about it yet. Hopefully scripts will just port over. // Windows can deal with those. It's not the worst thing on earth. That's not the path problem is like the least of Windows differences. What's the next big thing after Windows? So just very vaguely, I think that we need some system of connecting nodes together and kind of managing multiple nodes and opening channels between them, and that sort of thing. What are the biggest problems people have with Node? Is that your question? A lot of people come to it and say, people can't program like this. This is impossible. Like this outside, inward, whatever spaghetti programming style is impossible to program in. I think those people haven't actually sat down and like tried to write a program or gotten deeply into it. And I don't think that that's really a huge problem. I think you can learn to deal, I mean, it's a different programming style for sure, but you can learn to deal with that style of programming. I think that would be the largest complaint. The second largest complaint is the point that Node is a single-threaded deal. So I mean, you can't get Node to be scheduled to multiple CPUs, right? So you can't, if you have this server, you can't naively take advantage of all the cores on your system. But we have ways of dealing with that actually by, I mean, we have a method of doing pre-fork servers and passing the server file descriptor between processes and accepting connections on each of them. I do think, as I said, what the next big thing for Node is, that there is some work to do with organizing these multiple processes and making that easier and more approachable and possibly more native to Node. One thing I didn't talk about with Windows is that 1 minute, 30 seconds. Okay. One thing I didn't talk about with Windows is that Windows really hates processes. And it's not clear to us right now how we are going to do the pre-fork server thing on Windows, because you can't actually do the IOCP accept on multiple processes on the same file descriptor in Windows. There's some trickery that we can do by having another thread and using select just for accepting sockets, and then you can kind of get that into the main IOCP event loop. But that's not what Windows wants you to do. They want you to have multiple threads in one process and use IOCP to dispatch to these threads. So one thing that's happening in v8 3.2, which is the version right after us, we're pegged to 3.1 right now, is they're doing v8, they have a new feature called isolates, which is basically, they used a lot of global variables and now they're all packaging them up into an object, so that you can start multiple VMs inside of one process. So these VMs are thick, right? I mean, they're 10 megabytes or something, right? They don't share anything, which is fine, but that could be used, and they're going to use this on Chrome. We could use it too to start multiple V8s inside one process and use IOCP to schedule the isolates onto threads as they become available. That would be the Windowsy way to do it. But we also don't want to get too far away from how UNIX does it. So it's unclear if we should split the implementation, or on Unix you use multiple processes, on Windows you use multiple threads, or if we should just try to port this threading idea to Unix. Threads. I mean, kids these days. No, I don't know. Okay, well, I guess I'm getting booted off. So thank you. Bye.